Hi everyone, I wanted to give you an example of a limiting reagents problem because I know a few of you are still having a little bit of difficulty with this, so I thought I'd work through one and just show you step by step how they're done. So this is question 1 from the second limiting reagent sheet I gave out. Look, you can tell it's a limiting reagents problem even if you didn't know because there are 2 masses specified in the question. So you can see up here we've got 80 grams, there we are, and 28 grams there. If you have 2 masses, 90% of the time, it is a limiting reagents problem, more than 90%. Okay, so this is limiting reagents. So, our question, we need to determine the mass of iodine which could be produced. Okay, so we need to know what this guy is going to be, the mass. Okay, first of all, we need to figure out which one of these is going to be limiting. And the way we need to do this is figure out how many moles of each we're going to use. So what we need to do is work that out. Now, I've recommended you do this away from your other equations because otherwise you might get a little bit confused. So let's do it down the bottom here. And we'll work out the number of moles for iodine, for the I2O5. Okay, I might zoom in a little bit. Okay, so there we are. Alright, so our number of moles is equal to mass divided by our molar mass. The mass, according to the question, is 80 grams. And our molar mass, if you add it up, I2 is, it's 127 times 2. There's 5 oxygens, which are 16 each. If you add all that up, you'll get 334. Okay, 80 divided by 334, 0.24. Alright, so that's the number of mole of this I2O5 we have. Now, we need to figure out the number of mole of CO2, of carbon monoxide. So how many, we've got 28 grams of that. So, N equals M over M. So carbon is 12, oxygen is 16, so carbon monoxide weighs 28, and we have 28 grams of it. So 28 over 28, it's pretty straightforward, is 1. But before we can do anything else, we need to work out the last thing we need to do to figure out which one's limiting, and we do this in red, is divide it by the coefficient. So we get 0.24 divided by 1, and we have 1 divided by 5. So that means over here we have 0.2, and over here we have 0.24. This one is smaller, this one is the limiting reagent. Okay, so remember, after you've found the number of moles to work out the limiting reagents, you need to divide it by the coefficient. Now, a few of you are getting confused at this point and using this number, this 0.2, as your number of moles, and it's not. All right, the only reason we've done these calculations is to work out which one is limiting. So what I would even recommend you do, cross this stuff out. We're not going to use it again, and it's just going to confuse you. So we figured out that carbon monoxide is our limiting reagent. Okay, so that's going to drive our equation. So let's put in, I've missed a step. There's 2 steps you should do with your red pen. First of all, you put in your arrow. Second, you need to divide every coefficient by the coefficient of your limiting reagent. So in this case, our coefficient is 5. So we're dividing everything through by 5. Oh, that's a bad 5. Let me draw that again. 1 over 5. Okay, so once you know the limiting reagent, divide everything through by that same coefficient. Well, let's go back to our black pen. Okay, so we're looking for the mass of iodine that's been created. So, again, we need to work out our number of moles of carbon monoxide, sorry. So, we do that the same way. So the number of moles of CO is mass divided by molar mass. The mass is 28. The molar mass is 28. So the number of moles is 1. Okay, don't get confused. That's why I've got you to cross this stuff out down the bottom, because some people are using that 0.2 and you can't use that. So the number of moles we have of carbon monoxide is 1. Now, we come across over here. The number of moles of any other substance in our compound is equal to the number of moles of the carbon monoxide, this thing, multiplied by the coefficient. Okay? So the number of moles of carbon monoxide is 1. Our coefficient for the iodine is 1 over 5. 1 times 1 over 5. That's our number of moles of iodine. Okay? And so 1 times 1 over 5 is 0.2 mole. So, remember, find the number of moles of whatever's driving your equation, divide right through by that coefficient, and then to find the number of moles of anything else, you multiply the original mole of your whatever's driving by the coefficients. Okay, so if we wanted to find the number of moles of carbon dioxide, for example, that would just be the number of moles from here multiplied by 5 over 5 this time, because this 5 over 5 is here. If we wanted the number of moles of I2O5 that we could actually use, we just do 1 times 1 over 5. Okay, so there's our 1 over 5 there, and our 1 has come from there. Alright, so that's how you find the mole of anything. But we don't need to do that stuff. We only need to find the moles of iodine. So, we need the mass of iodine. Okay, and if we rearrange our original equation, we can work out mass is equal to the number of moles multiplied by the molar mass. So our number of moles is 0.2 multiplied by our molar mass, which is 254. 127 times 2. Okay, so if we work that out, and I just realised I have completely forgotten to work that out before I make this video, bear with me. Okay, I'm going to have to do this the long way. Where's my calculator? Sorry, this has all gone horribly wrong. So, it is 0.2 multiplied by 254, which gives us 50.8. Okay. Which is equal to 50.8 grams. Okay, it was worth the wait, wasn't it? Alright, so this is our final answer. Okay, so they're the steps that you need to take in order to find out, the mass of anything. Remember, these things down the bottom, they're only to find out the limiting reagent. I would recommend you do those away from your other calculations and then cross them out when you're done. And then, once you've figured out which one's limiting, start over. Okay, as you can see here, we've worked out carbon monoxide's limiting, and we've worked out a number of moles from scratch. Okay, so I hope that's helped. Please let me know if you have any other questions.